All right, so we're going to go ahead and move on to the last section in Unit 4, which is combinations of functions, okay? And there's a lot that goes into this section, so make sure you watch the entire video before you attempt this assignment on the Newton homework, okay? So when it comes to combinations of functions, we have two different types. We have algebra of functions, and we also have composition of functions. And I'm going to go over those separately so that we don't get confused, okay? So looking at the algebra of functions, basically we take two functions, which we're going to call f and g, and we can create four new functions, okay? We can create an addition function, which we write as f plus g of x, and what this means is we're basically just taking our f of x function and adding it to our g of x function, okay? Same thing with our subtraction function. We write this as f minus g of x, and all this means we're doing is taking our f function and subtracting our g function. So if our g function happens to have more than one term, we need to make sure that we use parentheses around it so that we know to distribute that negative to every term within g. Okay. Same thing with a product function. We write it as f times g of x. And this means we're taking our f of x function and multiplying it by our g of x function. Okay, so this could be maybe we have to distribute or FOIL, something like that. And then we have our quotient function, which is f over g of x. And this is where we're going to take our f of x function and divide it by our g of x. Now, I know some of you know how to do polynomial division. We're not going to do that for this section, okay? So once you get a function over a function, we want to make sure it's written as just a regular fraction, not a complex fraction. So that's something we would have to simplify. The other thing is all we're really going to do is look at, can we factor the top, can we factor the bottom, and cancel common factors, okay? So we're not going to be doing long division to simplify this, okay? And this is specifically where our g of x function cannot equal 0, obviously, because it's in the bottom of our fraction here, okay? So what I'm going to do is I'm going to give you an f and g function, and we're just going to calculate all these new functions so you get a little bit of practice coming up with those new functions, okay? So let's go ahead and look down here. Creating new functions. So given the functions f and g, they're listed here below, we want to come up with the addition, subtraction, product, and quotient functions. Okay, so I'm going to go ahead and just write over here. We're going to start with f plus g of x. Okay, we're going to start with our addition. And remember that addition function means we're just taking our f of x and we're adding our g of x function to it. Okay, so our f of x function is negative 2x squared plus 4x. Okay, and then we want to add our g of x function. So we're going to add negative 2x plus 4. Okay, so here notice I use parentheses, but I don't necessarily need them, right? Because I don't have to distribute a positive sign. So I can actually just drop my parentheses here. I'm just going to erase them. Drop my parentheses here and combine any like terms that I have. So the only like terms that I have are 4x and negative 2x, which means that my addition function is going to look like negative 2x squared plus 2x when I combine my x terms plus 4. And I just leave it like that. Okay, not too bad. So let's look at our subtraction function, which is f minus g of x. So that means we're going to be taking our f of x function and subtracting our g of x function. So this is going to look very similar to what we just did up here, right? Except instead of a plus, we're going to have a minus there. So when we have a minus, we do need to use parentheses so that we can make sure that minus gets distributed. Okay, so we have our f of x function, which is negative 2x squared plus 4x, and then we're subtracting our g of x function, which is negative 2x plus 4. Okay, now the first function I didn't really need the parentheses on because there's nothing being done outside of them, so I can go ahead and just drop those parentheses. But I did need the parentheses on the second function because I need to distribute that negative to both terms. So that gives me a positive 2x and a negative 4. Okay, and then again, I just combine my like terms, which is my two x terms. So I get negative 2x squared plus 6x minus 4. Okay. And I just box it in. Okay. Let's move on and look at our product function. So if I want to look at fg of x, remember this means that we're going to do f of x times g of x. So we're just multiplying the two functions together. So we're multiplying again. I'm going to go ahead and use parentheses. So my f of x function is negative 2x squared plus 4x. My g of x function is negative 2x plus 4. And then I need to go ahead and distribute this out, right? So I'm going to do negative 2x squared times negative 2x, which is going to give me a positive 4x cubed, right? Then I distribute my negative 2x squared to my 4, which gives me a negative 8x squared. And now I need to distribute this 4x. 4x times negative 2x gives me negative 8x squared. And I'm going to go ahead and line those up because they're like terms. And then 4x times 4 gives me a positive 16x. And then the only thing I have left to do is combine my like terms. So I have 4x cubed minus 16x squared plus 16x. And I just leave it like that. Okay? Let's look at our last one, which is our quotient function. So we're doing f over g of x, which means we're putting our f function on top and our g function on bottom, and we're going to see if we can factor and reduce this. Okay, so our f function is negative 2x squared plus 4x, and our g function is negative 2x plus 4. Okay, so I'm really looking to see here if I can factor and reduce. Now remember, I can't cancel x's or 2's or x squareds or any of that unless this is completely factored. So right now I can't reduce it the way it's written. So I need to look, do I have a greatest common factor on top? And I do, right? I can pull out an x. So if I pull out an x, I'll be left with negative 2x plus 4. And then on bottom, I could pull out, actually I can pull out more than an x. Silly me. I can pull out a 2x. So let's pull out a 2x on top, which will leave me with negative x. If I pull 2x out of that second term, I'll get plus 2, right? And then on bottom, I have, I can also pull out a 2, right? They have a 2 in common. So if I pull out a 2 there, I'll be left with negative x plus 2. Okay, so you can see we have the same quantity on top and bottom, so I'm going to go ahead and cancel those. And I can also cancel my 2's here. So notice all I'm left with is x. Okay, not too bad, hopefully, just creating new functions and simplifying. So on the next page, there's one for y'all to try. I've given you 2 functions, and I want you to go ahead and work out, figure out what the sum, difference, product, and quotient functions are. And then whenever you're ready to check yourself and go over these problems, unpause the video and we'll see how you did. Okay? All right, so we're going to go ahead and talk through the practice problems. So the first one, you're doing a sum of the functions. So you're taking your f function and you're adding your g function to it. Because we're just adding, we can drop the parentheses and combine like terms. And here the only terms we can combine are our x terms, which happen to be opposites. So they cancel out and we should just be left with 4x squared minus 4. When we do our subtraction function here, okay, our difference function, we can go ahead and subtract. Don't forget to distribute that negative to both terms. So that's going to make it a negative 4x and a positive 4. And then we combine like terms to simplify. So since I have 2 negative 4x's, I end up with a negative 8x. Okay. When we do our product function, we're multiplying. So again, just distributing. Distribute 4x squared to both terms. Distribute negative 4x to both terms. And then you should be able to combine 2x squared terms to end up with 16x cubed minus 32x squared plus 16x. Okay. And then our last one is our quotient function. So we put our f function on top, our g function on bottom. We factor them both completely because remember we can't reduce unless we have this completely factored. So when we factor it completely, we should be able to cancel an x minus 1 quantity and also a 4, which leaves us with just x. Okay? All right, so I want to go ahead and move on now. So what we've done so far is we have just come up with new functions, right? We've been given an f and a g, and we're coming up with new functions. So what I want to show you now is how to evaluate using the algebra of functions. And there's two ways, okay? If you are given two functions, let's look at this first example. It says f minus g evaluated at 5. So what I could do is I could figure out what this new function is first. I could find this f and subtract the g and come up with that new function and then plug the 5 in. Or I could plug this 5 in to each of these individually and then just subtract them, which I think that's the easier way. So that's what I'm going to show. Newton may show it just a little bit different. I'm not sure. So use whichever method you feel most comfortable with. Okay. So when we have f minus g of 5, this really just means we have f of 5 minus g of 5. So I just need to figure out what these two things equal. So I'm going to come over here to the side, and I'm going to figure out what f of 5 is. So I take 5 and I plug it into my f function everywhere I see an x. So that's going to give me negative 3 times 5 squared plus 5 minus 3. And then I just need to simplify that, right? We do our square first. So 5 squared is 25. And then 25 times negative 3 gives us a negative 75 plus 5 minus 3. So negative 75 plus 5 is negative 70. Minus 3 is going to give me a negative 73. Okay, so we just figured out that f of 5 equals negative 73. So I'm just going to replace that down here. Okay, and then I want to subtract whatever g of 5 is. So again, off to the side, I'm going to calculate what g of 5 is by taking 5 and plugging it into my g function where I see x. So my g function says to do my input plus 3. So I'm going to do 5 plus 3, which gives me 8. Okay, so g of 5 equals 8. So now this is really easy to simplify, right? Negative 73 minus 8 gives me a negative 81. Okay, so notice when you're evaluating, when you have an actual number to plug in, we don't even have to come up with that new function. We can just use our existing functions, plug the number in, and then do the operation. Okay, so let's look at another one. Here we have f times g of negative 1. So this is the same thing as saying f evaluated at negative 1 times g evaluated at negative 1. So I need to know what these two things equal. So off to the side, I'm going to go ahead and calculate what f of negative 1 is by plugging negative 1 into my f function everywhere I see an x. So I have negative 3 times negative 1 squared plus negative 1 minus 3. And then I just need to simplify. Remember, I do exponents first. So negative 1 squared makes that a positive 1. And then positive 1 times negative 3 is a negative 3. Okay. And then I have a minus 1 and a minus 3 here. And when I combine these, negative 3 minus 1 is negative 4. Minus 3 gives me negative 7. Okay. So I'm going to go ahead and replace my f of negative 1 with negative 7. And I want to multiply that by whatever g of negative 1 equals. Okay. So over to the side, I'm going to figure out what g of negative 1 is. Remember, my g function says to do my input plus 3. So I'm going to do negative 1 plus 3, which gives me 2. So I'm going to replace my g of negative 1 with a positive 2. And now all I have to do is multiply those two together. So negative 7 times 2 gives me negative 14. Okay, not too bad maybe? All right, I have a couple more examples to do on the next page, and then I'll let y'all try some. So same idea here, just trying two new operations, two new functions, or maybe the same function of the last page. All right, so f over g evaluated at 0. Again, this just means f evaluated at 0 divided by g evaluated at 0. So I need to figure out what these two things equal. So I'm going to go over here to the side, and I'm going to plug 0 into my f function. My f function says to do negative 3 times my input squared plus my input minus 3. So I get negative 3 times 0 squared plus 0 minus 3, right? 0 squared is 0 times negative 3 is 0 plus 0 is 0 minus 3 means this just equals a negative 3. So on top, I have a negative 3, and on bottom, I need to figure out what g of 0 equals. So I'm going to plug 0 into my g function, which says to do my input plus 3. So 0 plus 3 gives me a positive 3. So I'm going to replace my g of 0 on the bottom here with a positive 3. So negative 3 divided by positive 3 gives me a negative 1. Okay, not too bad, hopefully. Let me look at one more, and then I'll let y'all practice some. So this one is an addition function using the same functions that we have up here. Okay, because we don't have an x here, we don't actually have to come up with the new function. We can just evaluate each function individually. So I'm going to solve this by doing f of 3 plus g of 3. Okay, and we're going to go ahead and plug these in. All right, so off to the side, I'm going to do f evaluated at 3. So if I plug 3 into my f function, I get negative 3 times 3 squared plus 3 minus 3. Okay, and right away I see the plus 3 and minus 3. Those are opposites, so those are going to cancel out. So I just need to simplify this. I do my exponent first, so 3 squared is 9, right? And then 9 times negative 3 gives me negative 27. So I'm going to replace my f of 3 with negative 27, and then I need to figure out what g of 3 is so I can add it to negative 27. So g of 3, when I plug 3 into my g function, it says to do my input plus 3. So 3 plus 3 gives me 6. So I'm going to replace my g of 3 with 6. Okay, so negative 27 plus 6 is going to leave me with a negative 21. Okay, maybe not too bad. Evaluating when we have a number is actually a lot easier than coming up with the new function altogether, right? Because we just get a nice little answer. I will tell you the biggest mistake that I see with these problems is people coming up with the new function and then multiplying it by 3. Remember, this is not multiplying, this is evaluating, okay? So whatever's inside these parentheses, that's what's going into the functions for x, okay? All right, so at the bottom of the page here, there's 3 for y'all to try. So go ahead and pause the video, and then we'll go over it and see how you did, and then we'll move on to composition of functions. All right, so here's our practice problems. On the first one, we're doing a subtraction. So we're doing f of 3 minus g of 3. When we plug 3 into our f function, we should get negative 18. When we plug 3 into our g function, we should get a negative 8. And remember, we're subtracting. So when we subtract a negative, those double negatives become positive. So negative 18 and 8 gives us negative 10. Okay, if you didn't get these numbers, double check your work over here. Okay, on the second one, we're multiplying. So we're evaluating f of negative 2 and multiplying that by g of negative 2. Again, we calculate g of 2 and f of negative 2 and g of negative 2 over here to the side. So we get negative 8 for f of negative 2, and we get 7 for g of negative 2. Then all we have to do is multiply those two numbers together, which gives us a negative 56. Okay. And then on the last one, we're evaluating, let's see if I can move it up so there's not a glare. We're evaluating f over g evaluated at 0. So that means I'm doing f of 0 on top, g of 0 on bottom. Okay. When I plug 0 into my f function, it equals 0. When I plug 0 into my g function, I get 1, and 0 divided by anything is 0, right? All right. So hopefully we feel kind of okay on that. If you're struggling a little bit, feel free to go back and watch it again or rework it. You can always attempt the Knewton, even if you complete the assignment. Remember, you can always go into practice mode to get some extra practice on it. So if that's something you need, please take advantage of that. Okay. All right. I'm going to go ahead and move on to our next topic. Okay. This is still within that same homework assignment. That is, I don't remember what it's called, combinations of functions. Okay, so we've talked about the algebra. We've talked about doing the sum, the subtraction, the multiplication, and the division of functions. Now what we want to look at is the composition of functions. And this is totally different, okay? Instead of taking two functions and just doing an operation with them, what we're doing is we're taking two functions and putting one inside the other function as its input, okay? So if we're given two functions, f and g, f composed with g looks like this. We write f and then a little circle g, make sure that's an open circle so it doesn't look like a multiplication, okay? And what this means is that we are putting our g function inside our f function, okay? And the way I like to remember it is whichever letter is closest to the x, that's going to be your inside function, okay? Whichever letter is furthest away from the x is going to be the outside function, okay? So, and we can do it both directions. We can do f composed with g, or we can do g composed with f, okay? Again, whichever function is closest to your x, that's the function that's going to be your input function, okay? So this time we would be plugging f of x inside of g, okay? All right, so let's go ahead and look at a couple of examples. So here it says, given the functions f and g, compute the compositions f composed with g and g composed with f. So let's go ahead and move down here, and I am going to look at f composed with g of x first. And remember, here our g function is closest to the x. That's going to be our input function. So we have f, and we're plugging g inside of f. So what I want to do is I just want to take whatever this g function is and write it in these parentheses. So if you look up here, our g function is negative x minus 1. So I'm just going to replace this g of x with negative x minus 1. Okay, right? We all agree that is the g function. So I'm just writing in what the g function is. Now that is what I want to plug into f. So let's see what f does to things we plug into it. F says we're going to do negative 3 times our input squared minus 2 times our input. So anywhere we see an x, that is where we're going to put our input, or whatever's in our parentheses. Okay, so I'm going to write it out just with parentheses so you can see what I'm saying. The f function says to do negative 3 times my input squared minus 2 times my input, right? And we're used to plugging in just numbers. But in this case, we need to plug in a quantity, right? We're plugging in the quantity negative x minus 1. So that means negative x minus 1 goes in this quantity, negative x minus 1 goes in this quantity. And this is what I need to simplify in order to get that composition function, okay? So remember, whenever we have a squared quantity, that means we have that quantity, negative x minus 1, times itself, negative x minus 1. And then I'm going to go ahead and just distribute this negative 2, which is going to give me a positive 2x plus 2. Okay, so in moving forward simplifying, I'm going to go ahead and distribute these two quantities. I'm just going to ignore that negative 3 and focus just on these quantities for now. So negative x times negative x is positive x squared. Negative x times negative 1 is positive x. Negative 1 times negative x is positive x, and negative 1 times negative 1 is positive 1. Okay. Now, remember here I was multiplying those quantities by negative 3. So now that I have it distributed out, it still needs to be multiplied by negative 3. Okay. So now I can go ahead and distribute that negative 3 into all of these terms. Okay. So negative 3 times x squared is negative 3x squared. Negative 3 times x is negative 3x. Negative 3 times x, again, is negative 3x. Negative 3 times 1 is negative 3. And then I have a plus 2x and a plus 2. Okay. All right, so now that I have it all multiplied out, I just have to combine like terms and then I'm done. So I have negative 3x squared, and then I have minus 3x and plus 2x that I need to combine. So negative 3 and negative 3 gives me a negative 6, plus 2 gives me a negative 4x. And then I have a negative 3 and a positive 2, which leaves me with a negative 1. So this is my composition function. Okay, so taking one function, whatever that function looks like, and sticking it inside the other function. Okay, so that was f composed with g. Now let's look at g composed with f. Okay, so I'm going to come down here and say g composed of f of x. This time our f function is closest to the x, so it's going to be the input function. Okay, so I'm just going to replace that f of x with what f actually is, which is negative 3x squared minus 2x. So negative 3x squared minus 2x. Okay, so this ugly mess is what I'm plugging into g. So let's look at our g function and see what it does to its input. So if I look at my g function says to do the opposite of my input and subtract 1. So I want to do the opposite of my input and subtract 1. And my input that I'm plugging in for x is whatever this ugliness is inside my parentheses. So I have negative 3x squared minus 2x inside my parentheses. And then to simplify, this is a lot easier than the last one, right? I just need to distribute that negative. So I end up with positive 3x squared plus 2x minus 1. And I don't have any like terms, so that's as far as I can go. And I'm just going to leave it like that. Okay. All right. Let me look at a couple more examples, and then I will let y'all try some. Okay. So on the next page, same idea. We want to do f composed with g, and then g composed with f of these two functions. Okay. So let's go ahead and do f composed with g of x, which means that I'm sticking my g function inside my f function. So I'm going to go ahead and write in what my g function is. My g function, if I look up here, is 2x plus 1. So 2x plus 1 is what I want to stick inside my f function. So I'm going to write out here what my f function does. My f function does 4 times the input squared minus 4 times the input plus 3. So I'm saying the input instead of x because this is what I'm going to be putting in for x. So I'm going to write parentheses everywhere I see an x so that I know that's where I'm plugging my quantity in. Okay, so this is my f function, and I've just put parentheses where there's x's. Okay, that way I can plug in what's in my parentheses, which is 2x plus 1. Okay, so once I plug in my values, now I just need to simplify this. Okay, I'm going to go ahead and write this quantity out as 2 copies of it, 2x plus 1 times 2x plus 1. And I'm going to go ahead and distribute this negative 4. So I get negative 8x minus 4 plus 3. Okay, and now I need to simplify this beast. So just like the last one we did, I'm going to go ahead and FOIL these 2 quantities first, and then whatever that equals, then I'll distribute the 4 into it. So 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. And 1 times 1 is 1. Okay, leave it in parentheses because we still have to distribute that 4 to this whole thing. And then over here, I'm going to go ahead and just combine these like terms. Might as well, right? So I have my minus 8x and minus 1 when I combine my negative 4 and my 3. All right, now I want to go ahead and distribute my 4 into all of this, which is going to give me 16x squared plus 8x plus 8x plus 4. And then I bring down my negative 8x minus 1. And the last thing I have to do is combine all my like terms. So I have 16x squared. I have an 8x, an 8x, and a negative 8x, right? So really a positive and a negative will cancel out. So I just have 8x. And then 4 minus 1 leaves me with a positive 3. Okay. So this is my function for f composed with g. So remember, whatever function is closest to the x, that's what's going inside. Once we know our inside function, that's what we're plugging in as our input into our outside function. Okay, let's look at going the opposite direction. So now instead of f composed with g, we want to do g composed with f of x, which means this time we're going to be sticking our f function inside our g function. So inside the parentheses, I want to go ahead and write what the f function is. So if we look at the top of our page, our f function is 4x squared minus 4x plus 3. So 4x squared minus 4x plus 3 is what we're going to plug inside our g function. So I need to know, what does my g function do? So if I look up here at the top, my g function does 2 times my input plus 1. So I'm going to write it out with parentheses. 2 times my input plus 1. And then my input is whatever's in my parentheses over here, which is the huge ugly, right? So I have 4x squared minus 4x plus 3 as my input into that function. And now I just need to simplify. So I'm going to go ahead and distribute this 2 to everything and then see if I have any like terms that I can combine. So 2 times 4x squared gives me 8x squared. 2 times negative 4 gives me negative 8x. 2 times 3 gives me a positive 6. And then I have that plus 1 out there that I'm going to bring down. So the only thing I can combine is my 6 and my 1, which leaves me with 8x squared minus 8x plus 7. And that is my composition function, g composed with f. Okay? All right, so on the next page, there is a practice problem for you to try. Okay, same idea. You're given 2 functions and you are to find the composition functions f composed with g and g composed with f. So go ahead and take a whack at those, and when you're ready, unpause the video and we'll go over them. Okay, so we're going to go ahead and look at this practice problem. When we do f composed with g, g is getting plugged inside of f. Our g function is 3x minus 1. So that's what we're plugging in to our f function everywhere we see an x, okay? So what I would do is I would just write out what your f function is using parentheses. So notice we're going to have a negative and then parentheses squared plus 2 times parentheses. So that's what we have here. Negative parentheses squared plus 2 times parentheses. And then go ahead and put in your 3x minus 1 where those x's were. Okay. Now it's important that you see that when we square this, we're only squaring what the input is. Okay. That negative was not in parentheses, so it is not being squared. It's just out front. Okay. So when we square 3x minus 1, we need to write it out as 3x minus 1 times 3x minus 1. And then once that's all distributed, then you can go ahead and distribute in that negative to all those terms. Okay. You also need to distribute the 2. And then when you combine all your like terms, you should end up with negative 9x squared plus 12x minus 3. Okay. Let's look at the other direction. Let's look at g composed with f. When we do g composed with f, this time we're putting our f function, which is negative x squared plus 2x, we're putting that inside our g function. Our g function was 3x minus 1. So we do 3 times our input minus 1. Okay. So our input here is negative x squared plus 2x. All we have to do is distribute our 3. And when we do that, we're not left with anything that we can combine. So that's our answer. Okay. So hopefully we're kind of okay with compositions. So this is different from algebra of functions, right? Because with algebra, we were adding, subtracting, multiplying, and dividing. We were doing an operation. With compositions, we're taking one function and sticking it inside the other function, right? So a lot different. So with algebra, we created new functions, and then we also evaluated. We plugged in numbers. So we're going to do the same thing with compositions. Excuse me. Now we know how to create new functions. So now what we're going to look at is evaluating, where we actually plug in a number and get a number answer rather than a function, right? Okay. So when we look at evaluating with composition functions, just like with algebra, there's 2 ways to do it. We can take the 2 functions and figure out this composition function, and then whatever that new composition function is, then we can plug -1 into it, or we can just evaluate this as we evaluate the composition, which is what I'm going to suggest we do. Okay, so remember, whichever one is closest to the x or closest to the input is the one that we will evaluate first. So what this tells me is that f is my outside function, and inside we're evaluating g of -1. So this is very different from the algebra, because remember in the algebra we just plugged -1 into g and -1 into f, and then we did an operation. This is not true. Basically, whatever our input is goes into our inside function, and then whatever that equals goes into our outside function. Okay, so this number does not get plugged into our outside function. Okay, so we're going to plug that number into our inside function. Okay, so over here, this is what we need to do first. Okay, is calculate g of -1. So I'm just going to come down here and figure out what g of -1 equals. If I plug -1 into my g function, I'll get -1 plus 3, which is 2. So what I want to do is just replace this g of -1 with what I just found it to equal, which is 2. So this is f of 2. Okay, and now that I've simplified that inside piece, now I can just evaluate f of 2. So that means I'm plugging 2 into my f function. My f function says to do -3 times my input squared plus my input minus 3. So everywhere I say input, I'm putting in 2. Okay, and then I just need to simplify this. I do my exponent first, so 2 squared is 4 times a -3 is -12 plus 2 minus 3. So -12 plus 2 is -10 minus 3 gives me a -13. Okay. So again, anytime we evaluate, it seems a little bit easier because we're actually plugging in numbers and getting out a number answer. What's different about compositions is whatever this input value is, we put it into our inside function. Whatever that equals, that's what we put into our outside function. So you can think of this as a little swooshy swoosh, right? You could say 0 goes into G, and then whatever that is, that goes into F. Okay, so let's look at this one. This one, F is still our outside function, and this time we have G evaluated at 0 as our input. So we're going to do what's in here first, okay, and we're going to calculate what G of 0 is. So if I plug 0 into my g function, I do my input plus 3. So 0 plus 3 is just 3. So I'm going to replace g of 0 with what I know it equals, which is 3, right? So now we just have f of 3. Okay? And then all we do is plug 3 into our f function. So we're going to get -3 times 3 squared plus 3 minus 3. Right? And I can see already I have a plus 3 and a minus 3. Those are opposites. So I just need to simplify this first part. 3 squared is 9, and 9 times -3 gives me a -27. Okay? All right, so I want to show you just a couple more examples, and then I'll let you try them. Doing this same idea, but using graphs versus the actual functions, okay? So I'm not looking for you to try to figure out what these functions are so that you can plug them into an equation. I just want you to use the picture to evaluate, okay? So let's look here. Remember, whenever we're evaluating, whatever is inside our parentheses here is our x value, right? And whatever this whole thing equals is our y value, or our f of x value. Same thing with g, right? Whatever is inside here is our x, and then whatever the whole thing equals is our y. So if we are given a number inside the parentheses, we are being given an x, and we are looking for the y, or the f of x value, or the g of x value, okay? So let's look at this first one. We have f composed with g evaluated at 3. So just like before, whatever is in here is what I want to do first. So I need to figure out what g of 3 is, okay? So if 3 is inside my parentheses, that's my x. So I want to figure out what is the y value when x is 3. So I go to where x is 3, which is right here, okay? And I'm evaluating this on my g function. So I want to, from 3, trace it to my g function line, which is down, okay? And it hits my g function right here. And so I want to know at that point, what is my y value, which here you can see is -1. So this just equals -1. Whoops, my pen's not working. Okay, so now I can replace this whole inside piece because we just figured out that g of 3 equals -1. Okay, so we want to now evaluate our f function at -1. Okay, so again, this is our x, and we're trying to figure out the y value on our f curve when x is -1. So I go to where x is -1, which is right here, and I'm tracing it up to my f curve. So this one's my f curve. So at -1, I trace it up till it hits my f curve, and notice at that point my y value is 2. So this just equals 2. Okay, kind of okay. I don't know why my pen all of a sudden is dying. Dying pen. That one doesn't work much better either. Let me see if I have a pen that works. Okay, all right, one more and then I'll let y'all try one. Okay, so this one we want to evaluate f composed with g evaluated at 1. So we do whatever is inside here first. So I want to see what g of 1 equals. Okay, so remember this is our x and we're looking for our y value when x is 1. So I go to where x is 1, which is right here, and I'm looking for my g curve. What is the y value on my g curve when x is 1? So I need to trace this up to my g curve, not this one, that's f. Okay, so I'm going to go all the way up to my g curve, and it hits my g curve right there. And you can see at that point, its y value is 3. Okay, so 3 is what I can replace g of 1 with. So now we just have f evaluated at 3. And I want to know what that equals. So now my x value is 3, and I want to figure out what is the y value on my f curve when x is 3. So I go to where x is 3, which is right here, and I trace it to my f curve, which is this one down here, and it hits my f curve right there. And its y value at that point, if I trace it across, is -1. So this just equals -1. Okay. Sorry, it's bothering me. You can't see that. All right. So that is all of the examples I have for this section. So on the next page, you'll have a whole page of practice problems. So the first ones are evaluating composition functions. Okay, notice I just want to point out here we have f composed with f. Okay, if we're going to do that, it's exactly the same as we do f with g, g with f. This is our inside function, so we would plug -1 into f, and then whatever that equals, plug that into f again. Okay, so you can compose a function with itself. So I want y'all to try those composition functions that are just evaluating, and then also do the graph down here, evaluating f composed of g at -3. And then whenever you're ready to check yourself, or if you get stuck, go ahead and unpause the video and we'll go over them. Okay? All right, so here we go. Let's see how you did. The first one, we're doing f composed with g evaluated at 3, which means g of 3 is my inside function. So I need to evaluate my g function at 3, which when I plug it in should give me a -1. So that means I'm going to be evaluating my outside function at -1. So I plug -1 into my f function, and I should get -3. Okay? Let's look at our next one. Now, I kind of gave you a hint here, right? My hint was it's okay to plug a function into itself, composed with itself, right? So this means we're doing f evaluated at f of -1. So we're going to go ahead and plug -1 into the f function, which should give us -3. And so -3 is now what's going to be plugged into my outside function, which also happens to be f. Okay, so when we plug -3 into f, we end up with -3. Okay, all right, and then our last one, when we plug in g composed with f of 0, notice I changed the order of the functions. So now g is my outside function, and f is the function that's going to be the inside function because it's the closest to my input. So we need to calculate f of 0 first. when I plug 0 into my f function, I get 0. So 0 is now what I'm going to plug into my outside function, okay? So g evaluated at 0 will give me 2, okay? All right, and then our last one is our graph, evaluating composition functions with a graph. So you can see here that we have our g curve and we have our f curve. And we want to evaluate f composed with g evaluated at -3. So the first thing I want to do is go to where x equals -3 and figure out what's my y value on the g curve. So when I go to x is -3, that's right here. And then I trace it up till it hits my g curve. And I can see that the y value at that point is 3. Okay, so this inside function equals 3. So now I'm going to take that 3 and plug it into my outside function. Okay, so we're going to do f evaluated at 3. So now 3 is my new x value, and I'm trying to figure out what the y value is on my f curve when x is 3. So I go to where x is 3, which is right here. I trace it up till I hit my f curve, and I can see at that point my y value is 2. So this just equals 2. Okay. All right. So that is the end of this function, which is, or well, this function. That is the end of this section, which is all about combinations of functions. So you should be able to complete that assignment in Alta Newton now. If you have any questions, please let me know. Happy to help.